Inequalities. Whenever we talk about inequalities, we talk about greater than, equal to than, less than, not equal to, greater than. So what does all that mean? That just means that if I have a greater than or equal to than, this means that it's going to be greater than some point and it can be equal up to a point. So it's half opened. It's closed at one end, opened at the other. If it was just greater than, then it'd be opened at all points, and it's just saying from one point it's just going to keep on going another direction. If it was less than or equal to, it's half open. Again, it's closed at a particular point, and it goes off into another direction. And we're going to work these out, and I'll explain more. So if it's just less than, then there's no equal to sign. It's both open on both ends. It's just going off to one direction. So I have this set builder notation that says that this set builds on x, where x falls between -2, and it may equal -2, and falls between 0, but it will not equal 0 because look, there's no equal sign there. And I want to know what does and or mean. So I'm going to explain to you what and or means in inequalities. So whenever I talk about and is the intersection, right? It's where we all meet at. It's where we all agree upon this one particular point. So and means intersection. It's also known, represented by this upside down U shape. Intersection. Or means union. Union means everything. So when you go to a family reunion or a high school reunion, whatever it may be, everybody's invited. There is no limits. As long as you were part of it or you knew somebody, they're all included. So there's no limit. So that's a union of everything, and that's a U. So I'm going to apply these two rules using this here. What I like to do is when I see that I have something like this, I graph this. I take me a line. And since the X is falling between two different points, let's go ahead and let's put this on two separate lines. And let's read it separately. And only because we're actually going to solve for these. If and only if they didn't ask you about and or, and they just said graph this, well, that would be easy done. We would say -2 is on this side of the 0 going closer to the negative infinity. And then 0 is a halfway mark on the line because we have negative infinity to positive infinity. And we see that it's closed on the 2 because of the equal sign. So we have a closed circle and we have a bracket. And since it's going off this direction, we're going to put the bracket facing that direction. This says x is all values between them. And this says x does not equal 0. So it gets an open circle with the parentheses. And if I write this in interval notation, and this is important, guys, interval notation would be bracket 2, 0 parentheses. And we always read, oops, excuse me, guys, I left off the negative sign. We always read left to right. The smaller number comes first. If you ever have infinities involved, it's always going to get a parentheses. It's always open on infinities because we cannot put a stopping point on infinity. So this would be my interval notation. This is my set builder. This is my graph. But what if you were asked to give the intersection of this? Well, what I would do is I would break this apart. I would say, okay, I have x, let me write a little darker. X is greater than or equal to -2. So what I would do is make sure on here that I put 0 exactly in the middle, or the best you can. Line up both lines where they're both on the same points. You can write negative infinity to infinity if you want to. Sometimes it helps with graphing, especially if you're going off to those directions. You'll know to plot that in your interval notation. And then I have x is less than 0. So now that I have this, let's shade this in. Thought I had another color marker. Yes. Here we go. Let's shade it in. This said x is greater than or equal to 2. Negative 2 at that. So we got 1, negative 2 would be right here. X is greater than, that means x is going to go off in this direction. Off to infinity. And it's got an equal to sign, so I'm going to put a bracket, a closed circle on the negative 2. Okay, and then it says x here is less than 0. No equal to, so it's an open circle here. And it says less than, so we're going to go off to negative infinity. I'm going to put a parentheses. So to answer the question about and, remember that's the intersection. So if it's the intersection, it's literally where they intersect at. If for some reason they don't share any points, we call that an empty set, and we would write it like this. That's called an empty set. That means they do not intersect anywhere. Well, let's check to see if this one does. We have negative 2, so if I drop it down, yeah, we're sharing that point. At 0, where this one ends, we come up. So our intersection here is going to be negative 2 to 0. And how I would write that is bracket negative 2 comma 0, which worked out great, right? That's how it was here. But it doesn't always happen that way, but most of the times it does. So this is great. So now I want to know about the union. Well, the union is everything. So we would literally say that it covered, and it so happened to work out since there is an intersection, it covered everything. If there wasn't an intersection, then the union would be what's on this side, unions, whatever's on this side. So now I'm going to write this as negative infinity, comma, to infinity. We also call that all real numbers. And that is the way of graphing using intersections and unions.